Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look again at polygons to create maps within your applications. This was our code at the end of the last video. What we're going to do today is we're going to take what we've learned about creating graphical polygons and we're going to use them to create a map. So we're going to change our poly array to having 4 elements. And our map is going to have a fixed size. We're going to make it 15 by 15. Storing the values in constants makes it very easy to change the size of our map. And we're going to have a new polygon drawing function. So we'll call this draw polygons, since it's going to be drawing more than one. And we will create a new function to perform this. Now this is going to perform much of the same functions as our previous function, which drew a single polygon. So the first thing to decide is where our polygon is going to start. Now we'll take the same logic as we had in the previous one, but we'll make the size of our polygons slightly smaller since there are going to be more of them on the screen. And we'll set our polygon count to be 4 because each polygon is going to have 4 corners and 4 sides. Now since we're going to step through the terrain map, which is going to be 15 by 15, we'll want a for next loop to perform that. So our first task is to create a for next loop using a variable to go from 1 to the maximum number, which is 15. So we will set up 2 local variables to perform that function, long R and long C. So for each terrain polygon, we need to work out where we're starting. So we need to set the X and Y coordinates of our polygon. Just as we did in the last video, we will reference our user-defined type and we will set the starting position for the X and Y coordinates. Now what we're doing here is we're using our long start, which is 250. We're adding on to that the long R multiplied by 25. And for each of the coordinates we're going to do exactly the same. So for our second coordinate we're going to use the long start plus long size plus the long R multiplied by 25. This is to move our rows down the screen. So now that we've defined the location of each of the corners of our polygon, we now actually have to draw the polygon. So just as we did before, we're going to use the Graphic Polygon command, referencing the user-defined type we've just been populating, defining the color of the border of a polygon, and defining the color we're going to use to fill our polygon in a solid fill. Since this is going to be a double for next loop, now between the beginning of both of the loops, we're going to increase the size of the Y start variable by 25 and we'll leave the X start where it is for the moment. Right, okay. Now we've done that, a quick compile to make sure we haven't missed anything. And then after we finish both of the for next loops, we need to use a graphic redraw to render our polygons to the screen. So if we try running that now, there we have our polygons drawn on screen. Now we seem to have a small problem with the last element of both the X and Y coordinates, but we'll double back on that one. Now this isn't a terribly exciting map because it's as if we were looking straight down on the train. We want something a bit more 3D looking to it. So we're going to set a horizontal offset on this one. So we're going to create a couple more variables. One for a horizontal offset And I think we'll do a vertical offset as well. Now we'll populate our variable for the horizontal offset and we'll set it to 15. And then as we step through each of our for next loops, we'll want to change the x coordinate by our offset. So that each time we step through this, we move a little bit more to the left. And as such, we will want to subtract our offset from the y coordinate. And let's try that. We've still got a problem with the drawing of our last box, but we'll come back to that. Right, after a couple of small tweaks to the number crunching, I think we have something that will now draw our polygons the way we want them. So if we try running our code now, we have successfully eliminated the problem we had with the last element of our map, and we now have a slightly 3D-ish look to our map. The terrain, however, is all entirely flat, as if you were looking at a flat seascape. What we want to do next is, for each of the corners of our polygon, we need to work out whether that is completely flat or whether it has some kind of height. So the next thing to do is to work out the height of the corners of our polygon. And this will be where our vertical offset comes in. So since we're going to be doing some kind of random approach to generating this height, we need to seed the random number generator. So we're going to use randomized timer using the clock to actually provide the seed for our random number generator. And before we start running through our terrain, we'll want to work out for each of the elements of our terrain how high it is. So we're going to create a new function called determine terrain. And we'll pass to that our newly created array of heights. And we'll be passing this array by reference. And the purpose of this little function is to work out which of the elements of our terrain actually have height. We're going to use a for next loop to step through each of the elements array to establish the height. We're going to create another small function whose job it will be to work out whether the offset is going to be either 1 or 0. In other words, is it going to be sea level or above sea level? And if it is 1, then we will set the height. And since we're setting the vertical offset to be around 15, we will set the value in our array to 15. Otherwise, the value is just going to be a 0. Now all we have to do is to create our VOffset function. Now this very simple function is going to use the rnd command to give us a value between 1 and 6. So at the moment we're going to try it with, for example, a 50-50 chance of being above sea level. So if it's 1, 2 or 3, it will return 1. Any other number will return 0. So we can try tweaking the value within this function to either get less or more land above sea level. So in our routine that actually generates the polygons, we now have to test that value to see whether the terrain is going to be above sea level or not. So we'll be wanting to actually set our V offset value. Now at the moment it's not been populated, therefore it starts off at 0. So in order to determine whether we're at sea level or not, so the definition of sea level will be where all 4 corners of the terrain we're looking at have a 0 offset in vertical. So what we'll do is we will create another variable called long C, and we will populate long C initially to be true. So we're going to assume that we're at sea level unless we discover that we are not. So the first thing to do is to pick up the value in our array to work out what the vertical offset is. Now remember, we've set this to be either 0 or 15. Now if the value is greater than 0, then long C becomes false. And we pick the same logic for each coordinate of the polygon. So we're now testing the next coordinate, and then we'll do the same all the way down for each of our coordinates, making sure we're looking at the right element in the array. So by the time we get to the end of doing all 4 coordinates, the long C variable will either be true or false. If the value is true, then we can draw the polygon just the way we've been doing in a blue colour. If long C is not true, then we must be on an above sea level polygon. So we'll draw that in a green colour. So if we try running that now, we'll see that our terrain begins to look a little more interesting. In those terrain squares where all 4 coordinates are effectively 0 in height, then we've coloured it blue. Where the values are greater than 0, then we've coloured them green. So you can quite easily look at that map and say, well, I can see where the hills are and where sea level is. Now we can try changing the value of our vertical offset to give us more sea or more land. So in here where we worked it out, we'll say, well, let's say we want less land. We've increased the probability of there being more sea level terrain. So if we try running that, we should see significantly more sea level terrain. Now we can also try tweaking the height of our offset for land. Now at the moment we've got that set to 15. If we, for example, move it up to 20, we get slightly higher hills. So as you'll see, with a bit of arithmetic and using the polygon command, we can draw some quite interesting terrain on screen. So each time we draw this map, it will be quite random in nature, driven entirely by the code we've supplied. So that's it for today. Thank you for watching.